Okay. So since we are live, we should be talking in terms of people who have joined early should subscribe our channel for many more such sessions. And this is Team Karyous, the 5 schools, like 3 Sivnadar schools and 2 Vidyagyan and 1 university, Sivnadar University. And it's a students-led STEAM club where we keep doing amazing things. So would you like to add something, Rachna ma'am or Mayank sir, if you are there?
Absolutely, Vinita ma'am. This is a very robust platform, like ma'am said, primarily led by children, and where children from all the 5 institutions, they come together to address the latest that is happening in the field of science and technology. Through this platform, we've had some very interesting sessions, including those on robotics, on particle physics, and we hope to carry this initiative and take it from strength to strength in future too.
Thank you, Rachna ma'am. We have 1 more minute. People are joining on YouTube. I can see 20 participants. Satvik is the lead of Karyous Students team. This is very important to recognize his hard work. This is very important, Satvik, that side by side, if you see you and Nista, if you see any queries or any question in chat box, please collect those questions and put it in chat box here so Dr. Sinha can address those questions as well. The audiences have started. Yeah, thank you, Satvik. Any relevant questions? And also, Satvik and Nista, if you know the answer, you can write answer then and there also. Side by side, you can put it in chat box so that Dr. Sinha can answer those questions. So are we ready, Dr. Sinha?
Yes, I'm ready. I hope you can see me and hear me.
Yeah. So we can start, students.
All the best, team.
Good evening, everyone. I am Rigdha.
And I am Sarah.
And we are your host for today. A very warm welcome to one and all present here. We have gathered here today to understand and commemorate the launch of Chandrayaan 3 that is made possible by ISRO. Today, we have the privilege of meeting and interacting with Dr. Akash Sinha, who will guide us through an insightful journey of lunar exploration.
Now, we would request Vinita ma'am to address the audience.
Thank you, students. It's such a privileged moment that Dr. Sinha is with us. Today, we watched him in our WCH at one of the campus where 6th, 7th, 8th graders were watching him, and so nicely he was addressing each and everyone's questions. It was not possible for all students of all 6 branches to join his session. So we requested him to be live on YouTube so that he can address the questions and he can address the bigger audience. And obviously his sessions are always there on Karyous site, and anyone who, if someone is missing this session, can revisit and see. Audience, this is very important to recognize the hard work of the students who are in Karyous team. Satvik, Suhana, then there is Tamanna from other campus, Rajat, Gulfam sir, Rachna ma'am. They are the teachers behind the screen, Mayank sir, Sakshi ma'am, and Manoj sir and Manisha ma'am from different campuses. It is also important to recognize Dr. Sinha's, fast and very quick response when we requested him to be on, live, and requested him to take a session so that all of us, all 6 campuses, interested students and faculties can watch online. So we welcome you, Dr. Sinha. Would not waste my time to introduce you. It will be nice, Dr. Sinha, if you just speak first 1 or 2 lines about yourself, 2-3 lines, and then students will start the panel discussion. Over to you, Dr. Sinha. Thank you.
All right. Thank you so much, Vinita ma'am. So excited to see all the students, the young students are doing the moderation and they're carrying on this event. It's very impressive to see all our students from Shivnadar, school doing so well and from Vidyagyan. So first of all, very delighted to be interacting with all of you. I also had a chance to interact with Shivnada Noida a couple of days back and was very impressed with the kind of questions you had asked. Quick introduction about me. I'm a founder and CEO at Omnipresent Robot Technologies. It's a company that specializes in making drones and robots. We've also been part of ISRO's Chandrayaan 1, 2, and 3 missions, especially developed some of the software for the Pragyan rover and also some of the modules that help in orbiting and landing. I've also been a MIT TR35 innovator. It's a list that MIT US releases. It has some, it has names of most of the big innovators you might have heard, whether it's Elon Musk, Zuckerberg, or Bill Gates and all of them. So happy to be part of that list. Earlier, I was at Carnegie Mellon doing my master's in robotics and then worked for Lockheed Martin and iRobot. But then came back to India, started my startup, and also been working closely with Shivnada family here, with the school and with the university, and very excited to be among all of you and looking forward to our interaction.
Thank you, sir and ma'am.
Dr. Akash Sinha, Assistant Professor, Shivnada University, is the founder and CEO of Omnipresent Robotech Private Limited, which developed the software for Chandrayaan 2. Chandrayaan 2 and Chandrayaan 3 are Indian space missions related to lunar exploration. Chandrayaan 2 was India's second lunar exploration mission, launched by the Indian Space Research Organization, also known as ISRO.
It aimed to further study the moon's surface, atmosphere, and mineral composition, building upon the success of the Chandrayaan 1 mission.
Unfortunately, during the landing attempt on September 2019, contact with the lander was lost just moments before the touchdown, resulting in the loss of Vikram lander and Pragyan rover. A projected follow-up mission to Chandrayaan 2 was called Chandrayaan 3. In order to overcome the failure of Chandrayaan 2 mission, Chandrayaan 3 was designed as a mission to try a second soft landing on the moon. Today, we have with us Dr. Akash Sinha, who is a notable researcher known for his contributions to the engineering sector. Dr. Sinha has consistently demonstrated his profound engineering expertise by providing groundbreaking research with broad ramifications. His numerous publications in reputable journals and conferences, as well as his involvement in cutting-edge initiatives aimed at addressing real-world problems, all prove his unwavering devotion towards science. Before we invite Dr. Sinha, we would like to showcase a video by Tarini Rai Singhania from Grade 3 Sanskar.
I didn't know Chandrayaan 3 will space.
Can we increase the volume? So this is our school student who is in primary grade and explaining a little bit of Chandrayaan Mission 3, what she has understood.
Very good.
Aircraft thing or like a small car, so it'll let. So then we'll know a lot about the moon and Russia. I don't know. I might have failed or something, but yeah. But I know about
Okay.
So Dr. Sinha, you have created a buzz. Yesterday you came and I believe the elder siblings have attended your sessions. Primary kids did not get a chance. So they all are excited to listen and I hope that they are watching you on YouTube. Over to you, students. Thank you.
This reflects the level of excitement and enthusiasm for Chandrayaan 3. And as we await this momentous occasion, I would like to hand over it to the moderators for the session, Kripa Talukdar from Vidya Gyan School, Sitapur, and Shreya Ranjan from Shiv Nadar School, Noida.
Thank you, Mrita. First of all, I would like to greet our guest, Dr. Akash Sinha. A very good evening, sir. It's an honor for my friends and I to have you with us today on the eve of the landing of Chandrayaan 3. So without further ado, let us proceed with the first question. What is so important about the south pole of the moon, even though it's so dangerous? Why did ISRO and the other space agencies chose the moon south pole for the lunar landing?
Very, very good question. Thank you so much. I'm really impressed. You asked the right question. So, this, I think the bigger question here also is, you must have seen suddenly there is a big interest in going to moon. It's like Russia, US, China, Japan, all of them have suddenly started, going out for moon. And in fact, all of this has happened post ISRO's Chandrayaan 1 mission. There's something that ISRO's Chandrayaan 1 mission did that nobody could do in 50 years of human exploration. And that was to find water on moon. And not just water in traces, but water in huge amounts. So water in huge amounts, not just in small amounts, but huge amounts of water. And when we found that much amount of water, what it meant that there is enough water to fill something like a dull lake. So it has like 600 billion kgs of water is what we found on Moon. So if you see the lunar map, most of this water is concentrated around the lunar south poles. So lunar south poles have a lot of promise of lots of water there. And if we end up finding this water and utilizing it, it can be used for further space missions. It can be used for building human colonies over there. And it can even be used for building rocket fuel, because water is there. You can create oxygen, you can create hydrogen, and that's rocket fuel. And then oxygen can be used to grow plants. They can be used for human colonies that can survive in controlled dome type environment. That means moon could become a place where we can inhabit it, where humans can live there. And this kind of thing was not possible unless we had found large quantities of water on moon. And most of these large quantities are on the lunar south. And so far, nobody has really been there. So that's why it's really important that we get there, we find out the water ice, and then in future, we find ways to utilize it.
Thank you so much, sir.
Thank you, sir, for your insights on the topic. We have seen that in recent times, the catapult method has been used in several missions. How is this more helpful compared to the traditional launch vehicles that were used in the past?
Right. So, coming to the catapult method, once again, the perspective that we have to look at is you all heard about Russia's Luna mission. And Luna mission, we all know it costed something like 16,000 crores. And, the mission got completed in about 5 days' time. But the catapult method that we use takes about 40 days. Interestingly, the catapult method also takes up only 5 days to get from moon to Earth. It's just that we keep on circling Earth for a while, and then we get to moon, then we keep on circling moon for a while. And the reason we do that is because we can use Earth's gravity to save a lot of fuel. Now, remember, Earth is also going around the sun at almost 1 lakh kilometers per hour, which means if you were at that speed, you could actually reach to moon in just 4 hours. Now, we could utilize some of this fact that the Earth has its own energy and the gravitational field of Earth can be utilized to accelerate the spaceship. So when we do that effectively, we end up using less and less amount of fuel. And that's why, the catapult method is preferred by our scientists.
Sir, there is a question from audience. Shreya, will you please loudly repeat the question from chat box?
The question says, "Sir, was the slingshot idea came from from the mission to Mars?"
Okay. So, and the student, this has been asked by Vinita ma'am or a student?
By a student on
Acha,
a
it's by a student, madam has posted it. Okay.
Yeah, it's
So
on.
let me put it this way. I'm sure the student has watched the Mangalyaan movie. It's in the Mangalyaan movie, they talk about this concept. But let me tell you, the Chandrayaan 1 mission that happened several years before Mangalyaan also used the slingshot method. So it wasn't for the Mars mission, we used it for the first time. It was used by Chandrayaan 1 mission as well.
Thank you, sir. So,
Vinita
going
ma'am
to the
is saying
next.
something, but I think she's on mute.
No, Satvik, is there any other question? Please check YouTube and ask before we proceed.
Not at the moment.
Okay. So students, you can proceed.
So going with the third question. A month ago, while I was going through the news articles, I read that the slingshot was attempted from the perigee and not from the apogee. Like, would there have been a difference in the mission if the slingshot was attempted from the apogee?
Okay, so let me try to share my screen just to show you how this is working.
Also, there are audience who are want to know the difference between apogee and perigee. So when you
Right, yeah. So we'll clarify that difference on this slide over here. Hopefully you can you see my screen in the slides?
Yes, sir.
Okay. So let's first understand. So when you're typically going around Earth or Moon, or for that matter, any planet or satellite is going around a heavier body, you never really go in a perfect circle. It's always an ellipse. And the reason why it's an ellipse is that there is a component of horizontal velocity, and then there is gravity, and then there is gravity of both the bodies. So both the bodies exert their own gravities, and that's why the orbit is a little elliptical. So when you see an elliptical orbit, you see the closest point. So for example, let's take this orbit of the Chandrayaan around the Earth. So there's a point that is very close to Earth. So this closest point is called apogee, and the farthest point is called perigee. Now what happens is that typically, this is almost like, imagine throwing up a ball in the air and then it's falling down. So when the ball is thrown up in the air, the further it goes away from Earth, the more it slows down. So when it is at its highest point, when it's at the perigee at the highest point, it will actually have minimum speed because it has slowed down enough so that now it will again start falling back on Earth. So from the perigee, it starts falling back. And then when it reaches the closest point, apogee, then it is at its maximum speed. It's at its similarly, as I was saying, if the ball is thrown up and once it falls back to the ground, and the closer it comes to the ground, the faster its speed is. So the difference here is that, at the apogee, you are at a very high speed and you are very close to the planet. And at perigee, you are at a very slow speed and you are at a far distance away from the planet. So now what happens when you want to achieve this slingshot and take a slingshot to Moon, how you want to use Earth's gravity? So what happens if you do it at the fastest speed? just a little bit of push. Because see, when we are trying to change the orbit, all we need is a little bit of push. We need to change the direction of this Chandrayaan the Chandrayaan module. So we just want to give it a little push so that its direction changes by a large margin. Now, the higher our speed is, the smaller push we will need to change it by a larger direction, because even if we give it a little bit of push and the spacecraft is going at a very high velocity, it will change its direction by a larger degree, because that push gets converted and it takes up energy from the already kinetic energy that the spacecraft has. So that's why this slingshot was done when it was closest to the Earth. However, when it gets to the moon, it will be reverse. Then we will slow down at the slowest point because it will be easier for us to slow down further. So that is the advantage of going it about in this manner.
Thank you, sir, for providing such clarity on the query. Sir, could you elaborate on the improvements made in Chandrayaan 3 software compared to Chandrayaan 2, which will lead to better performance and data collection in the years to come?
Shreya, your speech is not clear. Your voice was breaking up. Can you please repeat loudly?
Sure, ma'am. So the question is regarding the improvements made in Chandrayaan 3's software and architecture compared to Chandrayaan 2, which will lead to better performance in the years to come.
So, see, there is a fundamental change in the software of Chandrayaan 3 compared to Chandrayaan 2. The hardware changes aren't that many, but there is the approach has changed. So the Chandrayaan 2 mission was designed on a success-based design. So it was given very strict parameters, and we had to make sure that we land in an area, a very small area of 500 by 500 meters. It was the area where we thought there are maximum chances of finding water. So we really wanted to land over there. And we wanted to make sure that whatever it takes, the spacecraft must get there. So what happened when we were, doing Chandrayaan 2 mission, there were certain restrictions in the software because of which, we could not land there properly. But however, in this Chandrayaan 3 mission, we've changed it to a failure-based design. So what that means is that instead of saying that you have to optimize for success, we are now optimizing to make sure that any degree of failure does not jeopardize the entire mission. So even if the software fails or one of the engine fails or we can't reach the proper landing site, the thrusting is not done correctly, the cameras have not captured the images correctly, at least we should still be able to soft land. So that is kind of sort of the fundamental change. Another change that has happened is that we have put in a lot more antennas this time. So our communication modules are much more stronger. Our Chandrayaan 3 lander module can communicate directly with Earth. It can communicate with Chandrayaan 3's own propulsion module. And it can also communicate with Chandrayaan 2's orbiter. So there are multiple communication modules available, which gives us a lot of redundancy here. Thirdly, we've also strengthened some of the landing gears on Chandrayaan 3. Now it can land at a much higher speed as well. So those are sort of the fundamental changes.
Excuse me, sir. There is a question from the audience. So do you think that there is a chance of Chandrayaan 3 landing before Russia's lunar project?
Oh, somebody is not following the news, huh? So I don't know if you heard it in the news, but the Luna 25 has unfortunately crashed while trying to deorbit. And that is also kind of the risk in trying to go and land very quickly because you have to orbit and deorbit very quickly. So I don't think ISRO was at all bothered about who was landing first and who was, going second or third, because our landing profile was based on when the lunar day starts on the site at which we are landing. And similarly for Russia, they had planned landing on August 21st because the site at which they were landing was further away from the pole, and at that place the sunrise would have happened by August 21st. So I don't think it was, how we had projected it as a fierce competition. I don't think it was that. I think there were two separate scientific experiments, and both had optimized their landing plans according to that.
So we have another question from the audience. Why was Chandrayaan 3 launched in the first place, even if we have sent two rockets already?
Why was the Chandrayaan 3 launched even though we had launched Chandrayaan 1 and 2? Is that what is being asked? Okay. So see, Chandrayaan 1 was just an orbiter mission. There was no actual soft landing on moon, and we didn't try to explore the lunar surface. The idea of Chandrayaan 1 mission was to be simply to be able to demonstrate that we can reach to the moon. Although we did had a controlled impact probe, which eventually found water there. Chandrayaan 2 mission and 3 were very similar. Their goal was to put a rover on Chandrayaan surface, demonstrate a soft landing, and thus be able to explore, how much water is there, what is the chemical composition, and so forth. So that way, but because we could not land properly on Chandrayaan 2 mission, that's why we went with Chandrayaan 3. But one of the good things we did was that Chandrayaan 3 costed 30% less than Chandrayaan 2, because one of the orbiter modules that was made for Chandrayaan 2 was again reused by Chandrayaan 3.
So there's another question from the audience. Why was Chandrayaan, how has the Chandrayaan 3 been made, like its part and programming? The name of the student who have asked this is Subra.
Okay, so how Chandrayaan 3 has been made? So, it's been made into several different modules. So there's a module called propulsion module, which essentially takes the Chandrayaan from Earth to the moon. And then once the propulsion module takes it to moon, then from the propulsion module, the lander separates out. And then the lander lands on moon. Once the lander lands on moon, then a rover comes out. And maybe we can see this once again with help of a slide. So let me get back to the slides over here. So it might be easier for you to understand. And so here we are showing you some of the different modules. Okay. So see, there's a propulsion module, which is carrying the lander and the rover. And it takes it from Earth to moon. Once it reaches the moon, the lander module separates out. So this lander module has these 4 legs, and it will land on the moon. Once the lander lands on the moon, a rover comes out, and the rover will do some on-site experiments. The rover is equipped with 2 cameras. It has got some spectrometer. It has got some drilling equipment. And there is, a lot of software in all of these pieces. But that is kind of the general architecture of Chandrayaan mission.
Related to this, Dr. Sinha, there is a question on my WhatsApp. I think some viewer is directly asking to me. And they're saying, is there a camera to capture landing on Chandrayaan Mission 3 in order to capture its soft landing process?
That is right. Yes, there is a downward looking camera on the lander module. And that camera will capture the actual soft landing. Yes.
Thank you. The moderators, it's very important to take few more questions from YouTube because the audience can't interact, but they are continuously writing questions on the YouTube channel. So there are some relevant questions I have already put. Please do ask.
Sure, ma'am. Right now, while I was listening to you, a sudden question came in my mind. How do you believe that the data acquired in this mission will shape the future of lunar settlement?
So see, we've so far we've not, in the sense, directly captured the water on moon. Huh? So I think that would be one of the big key findings if we are able to directly capture on some of the water, or I would say the best case scenario would be if we are able to actually land on some water ice or maybe nearby and get a good rough estimate or identify a few craters that have large amounts of water. I think those would be some very helpful outputs from this mission, because if we are able to do that, that could pave way for us to set up lunar colonies. And also, one of the things we have to realize that in space, a lot of collaboration happens. And so ISRO shares a lot of data with NASA. NASA shares a lot of data with ISRO, European Space Agency, Russian Space Agency. They all work together, and they all share data with each other, and they all help each other. And so there is NASA is planning a new moon mission where they plan to send astronauts on moon again by 2025 or 26 or so forth, or maybe it might happen by end of this decade. But they will also benefit from Chandrayaan mission, because once they see the data, they will understand where to land, how to build these plans. So it will eventually help us progress into a direction where we could build human settlements on moon, maybe even have space tourism that takes us to moon and back, and then also set it up as an international space station on moon.
Thank you, sir. So now I must ask you a question from a more robotics background, as it is a shared interest between us. So, what are your thoughts on the advancements in artificial intelligence and its effect on aeronautical engineering and software development?
You see, one of the great things artificial intelligence is doing is that practically almost everything that humans are doing, at some point, artificial intelligence will also be able to do, and probably be able to do it better than us. And that doesn't mean that things will end up for us. Then we'll start taking up even bigger challenges that we don't even think about right now. Now, let's say, for example, you saw the first image of a black hole that was generated by taking lots of data from multiple telescopes over a large period of time, and then a lot of AI was used to predict how the actual image of the black hole will look like. And similarly, a lot of such problems can be addressed in our space missions. For example, we'll be able to figure out using AI what would be good areas to explore, to land, to build human settlements, how will they survive, what will be their future, and so forth. When you talk about aeronautical engineering, there's a lot of AI that will start getting used in aerial maps. And a lot of aerial maps are generated using drones nowadays. So when we start using aerial maps with drones, there's a lot of data, and we can use AI to figure out what is going on in that data. So for example, we can figure out what kind of land is being used for what use. It is being used for agriculture, or is it being used for building infrastructure? If there is a land that has been devastated by flood, what is the kind of damage there? So all of these places, I think AI will be very useful.
Thank you, sir.
There is a related question. Could you please see there how the programming and the Chandrayaan Mission 3, this launcher was made? A very basic question, but yeah.
You're asking how the programming of Chandrayaan 3 was done?
Yeah, basically the audience on YouTube want to know that as the Chandrayaan Mission 3 is going in orbit, how the programming and everything is done from here, how in the initial phase, how the the satellite
Okay.
was made, how the robots and
So see, 99% of the programming is already there. It is loaded on the on the module. And it's only sort of small 1%, for example, performing orbital maneuvers. Then we send a signal when to perform the orbital maneuver, when to change the orbit. It's only these small pieces that we are actually sending from the Earth. And then once the module lands on Moon and the rover comes out, then it is even more autonomous. The only thing then that happens is that intermittently, once we get data from the rover, we can tell the rover to go to this position and try this out. But then the rover's own movement, nobody will control. You just tell it to go to a certain location, it will try to go there. So I would say 99% of the programming is pretty much done. Only 1% is being controlled from here.
Excuse me, sir. There is a question from the audience. While there is a camera on rover, will there be another camera shot from propulsion capsule or Chandrayaan 3 orbiter?
Just want to understand the question again. You said would there be another camera on the propulsion module?
Propulsion module or Chandrayaan 3 orbiter.
So let me tell you something. This time we have 11 cameras on Chandrayaan mission. Lots and lots of cameras. 3 cameras are there on the rover, and multiple cameras are present on the lander, and there is a camera on the propulsion module as well. So all of these modules have multiple cameras, and we will be able to capture various types of angles and various types of scenarios this time. So there is really no dearth of cameras this time.
There's another.
Besides water, are we looking for any other mineral on the lunar surface?
So yeah, there is always a possibility that rare earth minerals are there on Moon. For example, there could be, expensive rare earth metals like
Dr. Sinha, there are some very quick questions. We can't hear you right now.
Metals, maybe something like uranium and other. Can you hear me now?
Now it's okay. Yeah, thank you.
All right. Okay, so I was saying that yes, there is a possibility that there could be lots of rare earth materials over there as well, and those could also be used for lunar mining.
Dr. Sinha, there is a student who is very excited to listen to you, and he is asking that what should students focus while on school so that they can join ISRO, tomorrow's specific subject, research areas or learning experiments, etc. So at school level, what should they study so that they can join ISRO and they can do some miracle like this? Over to you, Dr. Sinha.
Very interesting. So I don't know if you know, ISRO has a satellite program where students from schools and universities are building nano satellites, and they're getting a first-hand experience of trying to build something for space. So I would say do find about go to ISRO's website and find about that program where they're able to build these nano satellites, and they're all being done with student teams. In fact, I heard that some tens or dozens of such student-made satellites were actually launched into space by ISRO. So that would be one good way. The other is there are some limited internship programs that ISRO has, and some of them are also for school students. There might be limited workshops, and I'm sure some of the students can go there. And I think similar programs are even offered by NASA. And this is something we can definitely find out and let students know how to interact there. But apart from that, even if you're not able to build the satellite and go there, there are things that you can start doing yourself. And so, for example, space has different things that you can do. One is excuse me. One is to build a rocket. That is about building a rocket engine. And I know that there are some rocket clubs. I think there is one at Shivnada University. I don't know if students have built something like that at a school, but if there is enough interest, some kind of a club like that can be built. So that is one part, is to build rockets. The other part is to build robots. Because eventually when the rocket goes and it lands there, then it will be taken over by a robot. Interestingly, this Mars mission that that NASA runs, it has a big robotic component, and its robot module is also headed by an Indian scientist called Vandy Verma. And it might be interesting for some of the students who are there to follow her on LinkedIn, on Instagram, and find out what they've been up to. And you may want to learn how to build a simple robot. I'm sure there's a robotics club in your school, but learning basics of robotics would be one more thing if you want to get into space. The third important part is the communication modules. So apart from the robot and the rockets, the third most important part is how to build antennas and communication systems that work in space. And that is also a big area of research. Again, that is something you can start learning yourself, maybe get a radio kit. There are some hobby radio kits that you can get. Try to build your very first radio. You might even have a radio club at your college or school. So those would be the kind of things that I would focus on. And then once you, I think what's important is that you get good at something, either towards building a rocket or towards building a robot or a communication module. And then you might as well, if you build a prototype, maybe put it up on your YouTube channel or Instagram, and then try to get an internship. Maybe you can send that video across to ISRO or even to NASA. And there are lots of space companies now coming up in India. And there is actually a space company that was started by a couple of college students. And I've heard that they're about to do their first launch, and they're doing very well. So it may not even be a bad idea to first start with some kind of a project, and then, maybe even start thinking about building a space company, because there's a lot of future in this. No?
Shreya, and the moderator from, I'm sorry, I'm forgetting name, from Vidya Gyan, there are so many questions. Every second I go on YouTube and I see so many questions. So it is very important to address as many questions as possible. We will be, with your permission, Dr. Sinha, can we extend the time till 8:30? I mean, 7:30 to 8:30 is already there, but can we extend 10 minutes more than that till 8:45?
Right, yeah, no problem.
So Shreya, will you please ask the question asked at YouTube?
Sure.
The students are writing with their names, Shreya. This is SNS Noida. So please ask this question. SNS Faridabad, SNS Gurgaon. I see many questions which are unaddressed.
One question from SNS Noida, a student named Uday, is asking how long the rover is supposed to last on the lunar surface.
Good question. So the rover is supposed to operate for one lunar day, which is about 14 Earth days. So for 14 days, there will be daylight. There will be some sunlight on the lunar surface where where our mission is going. So the rover will be functional for that period. Beyond that period, it may not get enough energy to recharge its batteries. In fact, for 14 days, then there will be a lunar night. Now it's possible that the rover might still wake up after being frozen for 14 days. And maybe it might work for a few more lunar cycles. But the design is only for 14 days or one lunar day.
So there's another question from the audience, from Shilpa Gupta. How long is the rover supposed to last on the moon? Like from Uday SMS Noida.
Yeah, I think this is the same question I answered. It's 14 days. Yeah.
Another question is, according to the plan, tomorrow they are going to attempt the landing. In case of an issue, why is the next date for landing on August 27th?
So see, what you have to understand is that the rover, the Chandrayaan module is in an orbit around the moon. So if it misses its landing schedule for whatever reason, let's say the moment it decides that I have to land now, and suppose for some reason that condition is not right, the Chandrayaan module is not going to stay at the same place. It will keep on moving around the moon. So even if it waits for another couple of hours, it would have already moved at a large distance from its intended landing site. So it may have to come back, do another circle around the moon, and then come back and do the landing. And that's why it has been planned for after 3 days.
So there's another question. How will Chandrayaan 3 get back to Earth? It's asked by Hardik from Shivnari School, Gurgaon.
So see, the Chandrayaan module is not designed to return back to Earth. It is a one-way mission. The rover and the lander will just stay on the moon. It's not really designed for it to come back, because that would mean that we'll have to again do a launch from the moon to get back to Earth.
I would like to ask you that both me, Kripa, and a lot of members on the YouTube live stream have also asked regards to what will India as a nation gain from this mission, apart from data and scientific achievement. What kind of improvements can be seen in other sectors like healthcare, like economic sector?
So see, there are some direct benefits and there are some indirect benefits. So direct benefit is that if we find out there is more water on moon, and if we are able to demonstrate that we can soft land on moon, then that would mean that we could probably soft land on other planets also. It will expand our horizon. It will establish our India as a superpower amongst the 2-3 countries that can reach the moon. And that is not a small achievement, because what happens is that helps build trust of a lot of foreign countries in India. Foreign investors, especially in space and aerospace, would want to then trust more and more on India. So that will establish India's credibility as an investment destination in engineering related fields, space related fields, and so forth. So those indirect benefits are then not limited only to the space and aerospace. Once that trust in technology builds, it will start helping all sectors, be it healthcare, be it education, be it other places. Thirdly, I think it will inspire a generation of scientists, like students like you, who take pride. For example, when we were in schools, all we knew was NASA, and everybody only dreamt of going to NASA, and the coolest job on earth was to work for NASA. Now we are changing that dream. Now we are saying that it's also great to be working for ISRO. We are just as good. So that change, that shift in the dream is also very important. Now, we don't want all of you best minds to simply go to America and not, work here. But when you see that things are also happening here, maybe a lot of you would not need to go to NASA, and they could still be contributing to our country over here. So as I said, benefits are direct as well as indirect, and maybe indirect benefits are far larger than the direct benefits.
So, our next question is, we all know that hundreds of people had worked hard for the second lunar mission of India, but sadly, it didn't reach the expectations that we had from it. So, if you could share your experience and what advice you would give us to cope up with failures.
So, see, I think the thing about failures is that, somebody was just telling me this morning that, if you are prepared to dive in the sea, then why be afraid of sharks? And so if you're going to be diving in the sea and you want to find out the real pearls that are inside the sea, there will be some casualties. Some people would even get bitten by sharks. When we first started building the airplanes, a lot of, those airplanes crashed. Yeah, there was a time when a lot of airplanes used to crash. But now we've got airplanes to a place where practically the chances of dying you in an air crash are almost zero now. And so similar is the thing with any kind of failure in life. You are bound to fail a few times, and you just need to understand that that's how success works. If you got success in the very first attempt, then either you planned it extremely well, or you were lucky, or maybe both. And so we need to keep a realistic view and not get deterred by failures at all. I think one of the philosophies that I'm seeing in startup world being followed nowadays is to say fail fast. I heard Mark Zuckerberg say this: fail fast and break things quickly. So I think we don't need to be afraid of breaking a few things, failing a few times. But what is important is that we do a good, diligent job. We analyze our failures. We learn from our failures. So the fact that you should not be scared of failures does not mean that you should take missions lightly, because each of these missions could cost a lot of money, time, effort. So every effort has to be put in, and it has to be done with a lot of diligence. But even after your full effort, if you fail somehow, then I think it's best to move on, learn from the failures, move on again. And as you will see in most space missions, there will be some failures, there will be some successes. But what I've seen is that even if you failed several times, but eventually once you succeed, most of the failures are then forgotten. So, once the Chandrayaan 3 succeeds, you will see very few people asking about Chandrayaan 2 mission. And so, and similar is the case. So I think in general about failures, I would say don't really worry about it. The moment you succeed, all of your failures, nobody's going to ask about.
There is another question. I was just curious to know, whether some specific incidents had led you to choose this profession of yours, or was it your interest in it?
So I would say it's been a mix of both, but yeah, I have always tried to, stuck to what I'm enjoying doing. And so I always wanted to build robots and wanted to build machines. So I went ahead and started studying robotics at a time when most of my friends were studying software engineering. And most of them told me that, there are no jobs in robotics, why you're doing that. And I think my viewpoint was just that if I would be doing something for rest of my life, I better do something that I really like. And so I wasn't sure if I'll get a job doing robotics because nobody was doing robotics at that time. But I think eventually it helps you out, because I think no matter which area or which field you choose, whether it is currently a hot topic or not, if you really enjoy that work, then you will success. You will meet, you will excel in that work. And once you start excelling and you become, I think your aspiration should always be that whatever you're doing, try to become best in that. Try to be the best in your field. Try to be the number one in your field, not just in your class, in your country, in the entire world. Even whether you reach there or not is a different story, but your aspiration must be that. Once I've chosen a particular field, I should be the number one person in that field. And that kind of aspiration will automatically come if you are really loving, what you're doing. So that's why I think it's important that you choose a field that you enjoy, that you love to do, and then it will become a lot more easier, because then you will not mind, even if you have to spend 12 hours 14 hours working in it, it will not feel like so much work. But if you're not enjoying it, even working for a 1 or 2 hours would feel like a pain. You will sit in office and you'll feel like running at, as soon as the office bell rings, your whatever is your timing, you just want to run away. But if you're really enjoying, then it will be like spending time with your best friend. The time doesn't matter. You will keep on working with what you're enjoying, and that will lead you to succeed. I mean, I really like the example of, let's say, the sportsman Neeraj Chopra. See, he took up javelin throw. No, but in a country where everybody only looks at cricket, he took up javelin throw. He enjoyed throwing javelin. He became the best in it. He set an example. So I don't think you really need to worry about which field has future, with what field has jobs. Every field has future, as long as you can be the best in it. And if you get into a field where there are too many people already, in any case, there'll be too much competition. And if you're in a field where there aren't that many people, then maybe the competition is even less. But irrespective of that, my simple advice is, don't worry too much about getting a job. Everybody gets a job, everybody makes a livelihood. But if you can get into something that you really like, you will excel in it, and then you will go much beyond, what you even aspired for.
Thank you so much, sir.
So another question from the YouTube live stream is, why do we use the gold foil over a lot of our satellites and also over the Chandrayaan 3 module?
Okay. So see, gold has a lot of properties that many other metals don't have, or maybe it's better at that. One is that it is an extremely good conductor of heat. Secondly, it is extremely malleable. You can produce very thin gold sheets, which means that when you are going to coat something with gold. So for example, if you might have seen the JSW telescope, that also has golden lining. So you can create very, very thin linings. Those will be very lightweight. They'll be very good conductors of heat, and they'll be very good reflectors. So any heat that is, let's say, directly coming from sun, it will be able to reflect, it will be able to distribute the heat, and the weight will also be very less. And so those are some of the reasons why gold lining is preferred.
So there's another question from the audience. Apart from money, are there any health and technical requirements for space tourism? It's Nivedita Ghosh from Delhi University.
Okay. So see, the money part will also come down. When initially space, air travel had started long back, it was expensive. Or you remember when mobile phones had first come, I don't think children would know that, but teachers would probably remember. When mobile phones at first come, every minute of phone call was like 32 rupees. So for every minute you talk, you had to pay 32 rupees. And that too was 32 rupees 20 years back. So that was probably something like paying up, 200 or 300 rupees for every minute you talk. So it was that expensive. So that money part will definitely come down. It will become quite affordable. Now coming back to other requirements. So one thing you will experience whenever you're doing space tourism is that you will experience periods of weightlessness, and there will be periods of very quick acceleration, which means you will be experiencing, as they call in, when you're training for fighter jets, you experience certain Gs, as they say, or if you've seen those, uh, you know, Mission Impossible movies, you might have heard that, you have to go at 5G and 10G. What that means is that, just like you can feel weightless, there will also be periods when you will feel higher weight. So you will feel as if your weight is 2 times, 3 times, 5 times than what it is right now. Now, those would be somewhat mellowed down, but I think there might be some kind of a training or a customization people might need to be done on Earth, but it will not be a lot. Just to give an example, recently Stephen Hawking also went into one of these weightless types, flights, which are called, I think they're called Vomit Comet or something like that. Where they take you into a plane, and then the plane side of just dips up and down so that you can experience weightlessness. So I don't think it will be big health requirements. It might be a little bit of a customization. I think if you can get onto some of the normal, not very heavy, but even the basic roller coaster rides, I think you should be okay. But if you're absolutely scared of roller coaster rides, then, maybe you may not enjoy it as much.
Thank you, sir.
So maybe you should get some training on, a few of simple roller coaster rides, and then you will be all set for space mission.
So another question from the audience. What qualities made Indian Chandrayaan a successful rocket for other countries?
So see, one of the things I think that ISRO has done, and I think if you see the larger question, ISRO, I believe, has a record of, I believe some more than 40 consecutive successful space launches. So it is one of the best, one of the safest, one of the, space organizations that has the highest track record of most successful space missions. So that, I think, is a matter of pride. I think we are far ahead compared to most of the space companies in doing that. And I believe we are able to do that because we do a lot of hard work in, planning out things, in simulating things, in testing everything out. And that's also partly because there's a lot of pressure, because when you're using this public money in India, where there are already a lot of problems to solve, at times people found it difficult to justify space missions. And I think that pressure even the scientists feel. And so I think they do an extremely good, meticulous job. But what has happened by doing that is that now a lot of other space companies are trusting ISRO. So you see, whenever ISRO does a launch, there will be payloads from NASA, there will be payloads from European space agencies. I think there was one launch where more than 100 satellites, a record number of satellites, were sent into space. And I think out of those 100, like some 90 odd satellites were from foreign countries. So you see, what has happened is that not just we have gained trust in our own missions, the world is also trusting us to send their satellites and rockets.
Sir, there's another question from the audience. What's the difference between Chandrayaan 3 and Luna 25's programming? From Shilpi Gupta.
Okay. So see, in some ways, Chandrayaan 3 and Luna 25 are similar. They were trying to land at a similar spot. They had a similar propulsion module and a similar lander module. Luna did not have a rover, so it was supposed to stay where it would stay. But its lander was much bigger. And it was supposed to operate for 1 year time period. Also, it flew on a much larger rocket, used a lot more fuel. It costed, I believe, some 20 or 25 times more than the Chandrayaan mission. So yeah, cost was a factor. I think mission profile was also slightly different. Also, it was trying to get to the moon quickly, so it had to orbit and deorbit at a much faster rate. In fact, Russia themselves admitted that the success rate was 70%. Even before the launch, they knew that the failure rate was higher. They were doing a risky mission, and there was 30% chance of it failing.
Moderator, you are requested to take care of script if there are many similar questions on YouTube which you can skip, and if there is any new question you can ask. Otherwise, please carry forward with your script. Thank you.
Thank you, ma'am. We would like to hand it over to Bridha and Sarah. They can take it forward.
Now we would request our Vice Principal, Manjama ma'am, to present the vote of thanks.
So, Shreya, have you, before Manjima ma'am says, Dr. Sinha, I would like to copy paste all the questions from YouTube, which are many more, and will share with you. Probably your answer or 1 or 2 line answer, we will take it from there and will repaste on YouTube, because this will always be there, so that all questions are answered. And over to you, Manjima ma'am. Manjima ma'am, are you there?
I'm here, but I don't have a lot of light on me. I'm really sorry. I am traveling right now on the road. Are you able to hear me?
Yes, and you were continuously listening us, and you were not a single moment you left. That also we can see.
Yes, it's been a fascinating discussion. And I just wanted to say thank you to Dr. Sinha for being here today and leading this conversation with so much grace, answering all the questions. We have a bunch of very, very curious students and parents attending this. And I think it's been a wonderful discussion so far. I got disconnected just now, so I don't know whether we are looking at ending already, or are we continuing this for a bit longer?
Time is up. That's why Sarah has, asked you to give a vote of thanks.
All right. So I would really like to thank Dr. Sinha for being here with us today. And this has been really an absolutely fascinating discussion. And I know we're all very eagerly looking forward to the mission being completed. And we're looking forward to the landing. I heard that there is a chance the landing may not happen tomorrow, but I hope for all our sakes that it does happen.
No, there is 99% it will happen tomorrow.
Yeah, I really hope that is the case.
Yeah.
I just want to add that Dr. Sinha will be live on BBC during landing, and obviously we will share another piece of information from your desk or from school desk about his on BBC as well.
We will do that. We'll certainly do that. And we hope that everyone is able to watch this absolutely momentous moment in our history. and we look forward to great things ahead. I would also like to take this opportunity to thank our student compares for today, and Shreya as well as Sarah. Thank you so much for being here and handling things. So we always like to be at the forefront. I know Vinita has been putting students ahead, asking them to take the conversation ahead because their curiosity keeps us going. So thank you so much, Dr. Sinha, for supporting us through this and for this absolutely magnificent session. Thank you. Thank you very much.
Thank you, Manjima. Dr. Sinha, this is very important to share that obviously Manjima is traveling, but still she was continuously live and I could see her.
Thank you so much for
Apart
joining.
from that, Dr. Sinha, I can see on YouTube, some of my ex-students from Sriram School also is there. And I can see on LinkedIn, they are writing that very glad to see you this very relevant session, ma'am, praying for the best outcome tomorrow.
Wonderful, wonderful. And we all hope that. And also, I know a lot of questions might have been left out. So one of the things I've been doing is that, if students want to reach me out, they can reach me at Instagram and, DM me their questions directly. Also, I'll be posting a series of updates and videos through Instagram or maybe YouTube, but I'll post the updates on Instagram. So that could be one good way to reach me out. I've also, put that in a comment in this, and this comment, if you want, you can share on the YouTube channel as well. So if students on the YouTube channel want to reach me out on Instagram, feel free to do that.
Could you please share your link, sir? Yeah, so that I can paste.
Yeah, I've just shared it in the comment.
Okay.
The Instagram ID, I've shared it. So if they just search that ID, Akash Sinha 08 on Instagram, they will be able to find me.
Okay. So thank you very much. Rachna ma'am would like to listen from you and Mayank sir first, and then we can say thank you to our dear students and the audience on YouTube. Over to you, Rachna ma'am.
Thank you, sir. Thank you, children. We have had a fascinating evening. And of course, like each and every Indian, fingers are crossed. And we look forward to a future filled with discovery, innovation, and pursuit of knowledge. Thank you so much, sir. Looking forward to more collaborations with you.
Over to you, Mayank sir. Could you please speak about it?
Sir, literally, I'm saying to you, it is one of the best sessions I have experienced. In the manner you showed the photographs and the technicalities, probably the explanation was so lucid, so simple. It's only a professor like you can do it. Thank you so much, sir.
Surely so much. And Mayank sir, it's good to see you are still in the lab, looks like, huh?
Yeah, yeah.
8:40 in the evening, you're still in the lab. Huh?
So
and also your student is also there, huh? A diligent student.
Vidyagan has some very good students and they are very hardworking.
Yes, excellent. Very good to see that.
So, Mayank sir, thank you very much. Rachna ma'am, thanks a lot. Satvik, who is always working, and always comes up, whether he is in mid of study or something. Thanks a lot, son. Without you, it would have been impossible. There are many good wishes on YouTube chat. You can watch that after this. You can just click. You will feel good about it. And people are really getting connected, and that feeling of nationality I can see during your session also. And they are wishing each other all the best for tomorrow landing, etc. And so audience at YouTube, Dr. Sinha will be again live on BBC tomorrow. What is your time of telecast, Dr. Sinha? Could you please?
5 to 7 or 8 p.m.
Yeah. So 5 to...
I'll share a link. It will be live online.
So please share so that I can share with the parent community as said by this. Thanks a lot. Thanks a lot, Shreya. Thanks a lot, the student from Vidyagan. Why your name is not written? It's written Mayank Agnihotri.
Actually, it's Mayank sir's laptop. That's why. My name is Kripa Talukdar.
So thanks, Bacha. You were so loud, so clear, and so confident.
Thank you so much, ma'am.
Thank you so much. Kripa, your name is Kripa?
My name is Kripa Talukdar. Yes.
Oh, thank you so much, Kripa, and thank you, Shreya and Sara and Mrigdha. I think you all were great. Thanks for putting all the great questions, and thank you so much, Vinita ma'am. I think you're the flag bearer and such an inspiration to all the students at our Shirnada community. And thank you so much, Manjima ma'am, for staying and attending this while you are still on travel. And Rachna ma'am for getting this organized. Mayank sir, I think all of you, it was wonderful to be part of this. And let's hope for the best. I'm sure we'll have some celebration coming tomorrow.
Yes. All the best to all of us. Thank you so much. So may I request Satvik to switch off the live telecast on